semicircular plate here. So it is having a radius r. Radius is r. Okay, this is having radius r. So we defined sigma, no? Area density m pi r square by 2 or 2m by pi r square. What is pi r square? Area of circle. Area of the disk. Half of the area will be the half of the area of semicircular plate. So 2m by pi r square. So this is what? Area density, not volume density. Linear density, area density, volume density. So this we define it as area density. Come for this. Now I assumed a ring of radius r and mass of this, let it be dm. What is this? What is the green color one? Semi-circular ring, no? Where the center of mass of this semicircular ring will be there at 2r by pi. 2r by pi. So I'll bring only semicircular ring. Where the center of mass of this will be. What is the radius of this ring? We have chosen this to be equal to r. So what is the location of this will be? How much it should be, that one? So 2r by pi. Location of center of mass of this ring. And what is the mass of that? That should be the dm, no? And what is the thickness of that? The width, better say width here. Shall we define the mass of that one? dm is equal to, let's proceed, sigma into dA. What is area of this strip? What should be the area of the strip? dA. So shall we do one thing? In a semicircular plate of radius pi plus pi r plus dr square by 2 by 2, or I'll write it. dA, this should be equal to pi into r plus dr whole square by 2. Is that okay, no? So if I subtract, I'll take a semicircular plate of radius r plus dr. In that, what will happen? I'll subtract a semicircular plate of radius r. Then I'll get the area of that strip. So this should be equal to how much? Sigma by 2. Dr square will be very small. Dr is very small, so dr square will be negligible. So total how much will get? dA is equal to dA dm should be equal to sigma into what is value of dA? dA will be only pi r dr. This is the mass of that elemental strip. Where do its center of mass will be? So now first we'll define dycm should be equal to ycm of that strip 2r by pi mass of the strip by integral of dm. Now try to see, I change it a little bit here. What we should write? 2r by pi. Why not r? At what distance the elemental structure is? Not at a distance r from the origin. Okay, no doubt. But here what happened? First we are finding out the location of. So here on the right hand side, sir, like why you are writing 2r by pi dm? Why you are not writing r dm? So what we are calculating? We are calculating the total center of mass of the semicircular plate. So like this, what happened? If I just take the moments of arm, or what you can say like m1 r1 plus m2 out of several semicircular strips here, semicircular rings. What happened? I'll get the total center of mass. Are you able to analyze here? You should not write r. You should not be write rdm. But sir, earlier you wrote at what distance it is located. Now what will happen? The semicircular plate is made up of semicircular rings. The position of center of mass of semicircular ring should be substituted here. Able to make it out? The definition. So now this should be, what should be the limit now? The limit should be 0 to capital R. So this should be equal to, no, 2R by pi. What is dm? Sigma pi r dr. Integral of dm will be total mass, 0 to r. So pi get cancelled. So 2 sigma by m integral of r square dr, 0 to capital R. 2 sigma m r cube by 3. Okay, let me substitute what is sigma. 2m by pi r square. Substituting that. R cube by 3. So how much we are getting? 4r by 3 pi. Now what about x coordinate? X coordinate will be 0. Xm will be 0 because the mass is distributed symmetrically about y-axis. So what is xm? Directly in the beginning only I'll write it. Okay, so this should be the semicircular plate here. The mass is distributed symmetrically about y-axis. So therefore, the x coordinate will be 0. Xm will be 0. You see how much of mass is present, how the mass is distributed in the first quadrant. Similar way, the mass is distributed in the third quadrant, second quadrant. So therefore, Xm will be 0. Now you look at this one. You should not write RDM. What we are doing here is now the center of mass of the semicircular ring should be substituted. Where the semicircular ring 2r by pi into mass of that semicircular ring. You should not write at what distance r is. What is r? R is just a position, no? Where the effective mass of this semicircular ring is located. That is what? 2r by pi. Now you can really ask a teacher this question. Sir, earlier you took r. Now you are not writing r. 2r by pi. Okay, let's go back. Let's go back here. What is this dm? Like it's a point mass, no? So for point mass, where the center of mass will be at its location only. So therefore, in fact, what is this r in the thing? R cos theta. I think all of you looking at r sin theta. What is r sin theta here? R sin theta is location of center of mass of that element from the origin. Also like a y coordinate of position of center of mass of that element from the origin. Is it okay? Since here the element was like a point, so therefore r sin theta I took here. So what is r sin theta? Location of y coordinate of center of mass